Hi, hello, welcome to another math lesson with me. We're going to be talking about lines and angles and proving theorems about them. Let's get started. So during this lesson, you're going to learn how to prove theorems about lines and angles using the vertical angles are congruent, alternate interior angles are congruent, points on a perpendicular bisector of a line segment are exactly equidistant from the segment endpoints. Most of these should be reviewed. You should have gone over them previously, so hopefully it's not too bad. All right. So vertical angles are the pair of angles that are created when two straight lines intersect. The image below shows a pair of vertical angles labeled A and a pair of vertical angles labeled B because the lines that are intersecting are straight. The opposite angles are congruent. Okay, this is all based off of that a straight line is 180 degrees. Okay, so if I have two straight lines and they intersect, right? So I have this green line, I have that red. So each of those are 180 degrees. So if I know that A is, say, we'll say 100 degrees, right? Well, if I look at B, well, I know B has to be 80 here and B has to be 80 here, which then makes A over here has to be 100. So the moral of this is I know those vertical angles have to be the same, and it's because of that 180 degrees for a straight line, if that makes sense. Alright, so special types of lines. We have parallel lines, which means that lines that have the same slope, thus will never cross or touch. And a transversal is just a line that crosses at least two other on a plane. So right now what we have, the picture we're looking at is I have two parallel lines. These symbols right here mean that those lines are parallel to one another, okay? And then they're cut by the transversal, which is this orange line right here, okay? So that's very special. We're going to talk about these different types of angles now. Okay, alternate interior angles, okay? So alternate interior angles. So all of these statements are going to say when two parallel lines are crossed by a transversal, the two angles on the opposite side of the transversal, but inside, so it's inside the parallel lines. The outer two lines are congruent, or this should be outer two angles. Angles are congruent. Alright, so this is looking at this angle and this angle. So angle 3 and angle 5 in this case are congruent. This still stems back to, so I have my vertical angles, right? 1 and 3, 5 and 7. This still comes back to proving this 180 things, having angles be what's called supplementary to one another, okay? Supplementary just means adds to be 180. So like angle 1 and 2 are supplementary, 2 and 3 are supplementary. But because of all these things, we know that these alternate interior angles have to be congruent. So very simply, 3 and 5 are equal to one another, and 4 and 6 are equal to one another. Okay, corresponding angles, okay? When two parallel lines are crossed by a transversal, corresponding angles are the angles on the same side of the transversal and the lines it's crossing. So like if we notice up here, my upper left of each of those parallel lines cut by that transversal. Because these lines are parallel to one another and I have the same angle being cut with this transversal, it's going to create the same angle, okay? And that'll happen for all four positions, okay? A perpendicular bisector is a line that is perpendicular. So if we remember, perpendicular means intersects at 90-degree angle to a line segment and passes through a midpoint. Midpoint is the middle of the line segment, okay? So equidistant just means they're the same distance apart, which means middle. Okay, perpendicular, there's my 90 degrees. Okay, complementary versus supplementary, we kind of talked about this earlier. Complementary angles are two angles that when combined add to equal 90 degrees. So right here, I have that angle, 30 degrees, this angle, 60 degrees, they add to 90. We say those are complementary to one another. Okay, the next is supplementary, which means two angles that are combined add to equal 180. As we talked about earlier, we know that a straight line is 180 degrees. So that means that this part plus this part has to equal 180, whatever that is. Alright, so a proof is just an argument in reasoning for a mathematical statement. Example, prove that angle 2 is congruent to angle 7. Okay, this symbol right here means congruent or equal, or the same. It's not really equal because we're talking about a measurement, so we'd say the same. A lot of the time when we're talking about geometry, instead of saying equal, we say congruent. I mean, everything's exactly the same. Okay, I think we're going to do a proof right here yet. Okay, so given that angle 3 is equal to 2x plus 7, and angle 6 is equal to 71, find angle x. So let's see. I know that angle 3 is equal to 2x plus 7, and angle 6 is equal to 71 degrees. Okay. So what do I know about these angles? So anytime I ask myself these, I need to ask myself a couple questions. Are these two angles complementary or supplementary? Well, they're not complementary. When I have two parallel lines cut by a transversal, there's nowhere that I'm going to have a 90-degree angle most of the time, where two angles add up to 90 degrees. Are they supplementary? Nope, they're not going to, these two angles aren't going to add up to 180. What they are, though, is notice that they're in that bottom right position in both parallel lines with that transversal. So I know that those are complementary angles. So I know that they have to equal one another. So all I have to do here is say, well, 71 equals 2x plus 7. Okay? Now I can subtract 7 from both sides. All we're doing is solving this now. So let's see, that's going to give me 64 equals 2x. Then I'm going to divide both by 2. And I get 32 degrees equals x. So I know x equals 32. That was my objective. Alright, another one. Given angle 1 is x minus 15, and angle 7 is 85. Oh, not 84, 85. Alright, so let's see. Are these complementary, or are these corresponding angles? Now let's see. Angle 1 and angle 8 would be corresponding, right, in the same position. Well, I do know something, right? Since those are corresponding, can't I say that angle 8 is the same as angle 1? So I know that's x minus 15. Well, now I can see a relationship between these two angles. I know that those two angles have to be supplementary, or they have to add up to be 180 degrees. So what I can do is I can say x minus 15 plus 85, I know is supposed to equal 180. Now I can combine my like terms here. 85 minus 15. And I get x plus, let's see, what's that going to be, 70 equals 180. Then I'm going to subtract 70 from both sides. I know x needs to equal 100 and 10 degrees. Okay? All right, next one. So pause the video. I want you to try this one on your own. Okay. Given measure of angle 1 is 120 degrees. Measure of angle 5 is x minus 8. Solve for x. All right. So we're going to do something very similar here, right? Let's say, all right, what do I know? Well, they're not corresponding angles. What I do know, though, is I know angle 1 and angle 3 are vertical angles. Okay? And then 3 and 8, I know are alternate interior angles. So I know 1, 3, 8, and 6. Those angles all have to equal one another. Well, how does that help me figure out this angle 5 thing? Well, angle 8 and angle 5 are going to be supplementary angles. So I can say that angle 1 and angle 5, by that logic, also have to be supplementary. So I can say 120 plus x minus 8 equals 180 degrees. I'm going to combine my like terms here. So I get 112 plus x equals 180. We're going to subtract 112 from both sides. I'm going to get x equals, let's see, we're going to have to borrow here, 8. So we got x equals 68 degrees. Perfect. All right, if you have any questions about this, please come and talk to me. I'm happy to help you out. And have a great day.